Yes, good evening to you there. My name is Mahad Sekakashaka, and I'm here to present Artificial Intelligence Assignment 2. Yes, my real life problem, yes, is to address the manufacturing of robots. The problem is that labor is so expensive. So to minimize expense or to make labor cheap is to implement robots in working in the field of e-commerce, mostly supermarkets. Yeah, that's where I targeted on. Yeah, in this it will make labor cheap. Yeah, so that services are acquired at a high level and products are produced highly. So how the dataset will be addressed: artificial intelligence and machine language training datasets. That is what I will use, because this would enable us to train the robots to acquire information. This will help us make the robots behave like how we want them to be. So 4 factors considered before using. The first one is the degree of human participation. Yeah, the degree of human participation. Input the information feeded into our robots. Yes, and then the future extraction, that is to process, that involves the dimension reduction. Classification includes predicting the class of a given data points. Output, this is the information put out, yeah, after processing. Then the 5 important features in the dataset, that is the accuracy. Information has to be accurate. That is the ratio of data to error. Yes, for you to create a good agent, so the information has to be accurate. The information you have fitted it in. Completeness, missing information will leave gaps in your AI machines. Precision, how the data is labeled. Scale, the versatility your data set, the better coverage it will give you your program. Timeliness, for certain industries and the use case in particular. Yeah, timeliness, the shorter period. So Bayesian theorem, this is a simple formula used to calculate conditional probability. Bayes theorem, it's a law, yeah, which states that the conditional probability of an event based on the occurrence of another event is equal to the likelihood of second event given the first event multiplied by the probability of the first event. Let me show it to you here. Yes, here there is a probability of this event, and whereby A and B are events. So the probability A over B is equal to the probability it means A given B, which is true. Then probability B given A, which is true. Then probability of A and probability of B, independent probabilities. So this is the formula, yeah, that probability of A given B is equals to probability of B given A times probability of A independently over, we will divide by the probability of B independently. Naive Bayes is one of the simple and most effective classification algorithm which helps in building the first machine language model that can make quick prediction. Yes, some popular examples, those are spam filtration, sentimental analysis, and classifying articles. Yeah, suppose we have a data set of weather condition corresponding to the target variable. Using using the data set, we need to decide that whether we should play not on a particular day according to the weather condition. Yeah, so step one, it will be to convert the given data set into frequency tables. Then step two, it will be to generate likelihood table by finding the probabilities of given futures. The last step, now here, use Bayes theory to calculate the posterior probability. Bayesian network, this is a probabilistic graph model for representing knowledge about an uncertain domain, where each domain corresponds to a random variable and each edge represents conditional probability for the corresponding random variable. Yeah, it can be used to build models from data or expert opinion. So this is an example. It's compact, flexible, and interpretable, representable, and joint probability distribution. Like for example here, it shows that alarm on, and it has a probability that alarm is on, yeah, and is true. Yeah, here you can see that probability is 0.9 and it's false 0.1. If you add it, you add up to 1. And here that the person overslept, that the alarm was yes, and but the person overslept, which is yes, is 0.1. Yeah, the probability that it is the alarm rang, yeah, and the alarm was on and the person did not oversleep, it is 0.9. Whereas the probability that the alarm was off and the person overslept is 0.9, and the probability that, as you see, you follow until where you see the bus late, that the person got a bus late, captured that. So we can continue. Yes, differences between Bayesian theorem and Naive. Yeah, Naive assumes condition, whereas Bayes theorem does not. Naive algorithm is very faster than Bayes theorem. Naive is a type of prediction model which assumes that all the futures are mutually independent, while Bayes' theorem is a theorem that allows us to infer the probability of particular model given observed data. So difference between Bayesian network and Naive Bayesian network model relationship between features in a very general way, while Naive Bayes is a simple model that describes particular class of Bayesian network where all the features are class condition. So these are my references I used. Yeah, these are my references I used to find this information. Thank you. Have a good day.